Hello students, hope you are doing well and set for this session, that is cubes part 2. In this case, we continue with the handout discussion LAHO 10311313. So till now in the previous session we had discussed with the different types of LR questions, LR concepts with cubes, and the last one was painting of the cubes and cutting into different pieces and three faces colored, two face colored, one face colored, no face colored pieces counting was discussed. That was the basic discussion last time, the last set. And now, this time we are going to discuss with some advanced version of those type of questions. So that time there was a painting. Initially the cube was painted completely with one color. Now this time the painting with the colors will be different. Okay, so all the faces will not be painted with the same color. Fine. So let us start, and we start with the question. Next question of the handout. That is question number 23 to 28. Just look at the question part here. A pair of opposite faces of a cube is painted yellow. Fine. Another pair of opposite faces orange, and the remaining two faces are painted white. Fine. So in this case, the whole faces, all faces of the cube was not painted in the same color. So in this case, there are three colors, okay, and the opposite faces are with same color. Fine. So a pair of opposite faces of a cube is painted yellow, another pair of opposite faces orange, and the remaining two faces are painted white. So when I try to make this figure, it looks like this one. So this one, okay. Now in this it is given that the cube is then cut into 343 smaller but identical pieces. So it is clearly mentioned that 343 smaller but identical cubes. This is possible if and only if, since this is a large cube and it is divided into 343 smaller cubes, it means in this case each and every dimension will have in total including the vertices, in total there will be 7 cubes, so that 7 into 7 into 7, 343, the concept will be used here. So number of cubes on each of the each of the dimension, along each of the dimension would be 7. So like if I talk about this here, so if this is the cube, okay, it can be 7 here, it can be 7 here, it can be 7 here, so that 7 into 7 into 7, 343 satisfies here. Now the next thing is opposite faces are with the same color. So it is given that a pair of opposite faces of a cube is painted yellow. So yellow this side, yellow this side. So these are opposite. White this side and white this side. So these are opposite. Orange this side top and orange bottom. These are opposite. Now again the question are of the same type as we have discussed in the previous session. That is, how many of the smaller cubes have all the three colors on them? Fine. Two colors on them. Okay. Three colors means two colors, one color, zero colors. So these type of questions are obviously is here to be formed. So let us start here. How to approach this question? How many of the smaller cubes have all the three colors on them? We had seen in the previous set that since three colors means three faces has to be there. It means that cube must be painted. The cube must have three painted faces. Fine. So until unless three painted faces are there, we cannot have the chance of having all the three colors, or all the means three painted faces pieces or cubes will be lying at which place? That is vertices. It means there are 8 vertices. 8 vertices at 8 vertices, the cubes which are lying here, these are three painted faces. Fine. Now we have to check whether each of the vertices are giving uh, three different colors or not. Now, in this case, it is given that uh, none of the no two adjacent faces have the same color, so there is no scope of any two faces at the corners being the same color. So since opposite faces are the same, so if I talk about this vertex, okay, there is no chance of its adjacent. If opposite faces are same, it means every colored face will have two adjacent faces which are with different colors, like yellow, orange, white we have here. So if I talk about this vertex has here yellow, orange, white. Now come to this. If I talk about this vertex, yellow, white, orange. Yes, this is also different. Okay. This vertex also contains all the three colors. Similarly, if I talk about this vertex, white, yellow, orange, again it has three different colors. If I talk about this vertex, again orange, white, yellow. Four vertices, these four vertices have all three different colors. Now come to this here, again orange, white, yellow is here. So this is also to be counted. Now come to this one, white, yellow, orange, this is also to be counted. Now come to this one, this is yellow, this is white, this is top is orange. Again this is all to be counted. It means in this case, all the eight vertices are having three colors. Okay, and three colors, if all the vertices have, then the cubes lying at the vertices obviously will have all the three colors on them. Okay, fine. So in this case, the question is here about smaller cubes with all the three colors on them, and now we have these all lying at the vertices. At lying on the vertices, in this case, the total number of such cubes will be how much? 8. 4 plus 4, 8, and total number of vertices is 8. That's why the answer is going to be 8. Answer choice we have as A. Let's look at the solution. I repeat here, it is given that since no two adjacent surfaces have the same color, each corner piece has three painted faces and each face has a, okay. That's what I have discussed just now here, that if I talk about this vertex, all the vertices have here three different colors available. Why? The reason being, no two adjacent faces are with same color. So since opposite faces are of the same color with the same color, so there is no chance of any two adjacent face having the same color, and in that case, no vertices have the possibility of two face being same. Okay, that's why we have here each and every vertex with three colors, and in this case our answer will be according to all the eight vertices, and the answer obviously is 8. I hope this is clear. So hence the total number of smaller cubes with all three colors on them is fine. Okay, so answer choice is here A. Now come to the next question. Question number 24. How many of the smaller cubes have only white and orange on them? Only white and orange. We have learnt in the previous set that two face colored pieces are lying on the edge, and we have to count those which have only white and orange. Only white and orange, it means only two faces painted must be there, and they must be lying on the. Just check here how many such edges are possible with white and orange. White and orange, this edge, yes, orange, white. Just look at this one, orange, white. This is also orange, white. Now look at this, orange, white. And it's just behind it, we have here this edge also white and white. Okay, is it clear? So how many such edges we have? Four such edges are available. Fine. And now at each of the dimension there were seven pieces available, and out of which these vertices based three face colored were removed. So the remaining how many are here? 7 minus 2, which is here 5 at each of the edges. Now how many edges we have here? that is 4 as per the demand in the question. The demand is of only white and orange. I hope this is clear. So in this case, there are five pieces on each of the edges. And how many such edges are available? 4 such edges are available. And in this case, 5 into 4, that gives us 20. I hope this is clear. So our answer choice for this question is, now I just want to uh, continue the discussion. Okay. So I have seen here only white and orange 4 edges. Similarly, can I say yellow and orange edges will also be 4? Let's look at this here and cross check. This is orange yellow, fine? Orange yellow. Now this is also yellow orange, and this face is yellow, okay? And this orange, so this is also orange yellow, and behind it this is also orange. Can I say orange yellow edges are also 4 in number? So number of orange yellow edges are again 4. Number of white orange we already have seen 4. Now the third type comes here as number of edges which are of the type yellow white. Okay, yellow white. Just look at this. This was white orange. This is orange yellow. Now this is yellow white. Now look at this one. So this is here yellow white, this is white yellow, this is white yellow, and behind it this is also. So how many such edges are available? 4 edges. So each of these type of edges are here 4. And I can also say that because of the symmetricity. Why? All of the colors are symmetrically present. The status of each of the color faces are same. Okay, so because of symmetricity, if one pair has 4 such edges, then obviously another means other 2 pair of the colors will also have the same number of edges. Fine. So total, if I talk about such pieces with exactly 2 colors on them, that is again 20 of orange white as we have discussed, 20 of obviously orange yellow, and 20 of yellow and white. So if I talk about total number of pieces with 2 colors, and that will be here how many? 20 plus 20 plus 20 is 60. Okay, if this is the question, then we can get the answer as 60. Okay, now get back to the solution. So number of orange white edges, number of orange white edges we have just counted here. Now similarly, number of yellow white edges are also 4, just we have counted. Number of orange yellow edges are also, each of such edges are 4. Total number of edges 12 we have. Now question is to find the answer for this type. So the number of cubes with orange and white colors on them only. Okay, so total these are lying on the edges, and the number of pieces on each of the edges is how much? 5. 5 into 4, 20. Okay, so the total number of pieces will be here 20. So now again number of 2 face painted pieces on each edge in this case is 7 minus 2, that is equal to. Hope this is clear. Now white orange edges into 5 at each edge. So number of white orange edges is how much? 4. 4 into 5, that is equal to 20. And the answer for this question is C, that is. I hope this is clear. Now move on to the next question. Question number 25. How many of the smaller cubes have exactly 2 colors on them? So I have just given you the hint of the discussion in the previous question that each of orange white edges, yellow white edges, orange yellow edges are 4, 4, 4 each. Okay, fine. Total number of such edges which are coming in the category of exactly 2 colors on them is how much? 4 plus 4 plus 4, that is equal to 12 such edges available. And at each of the edges we have how many? 5 pieces. So total number of pieces will be 12 into 5, 60, or you can also say 20 orange white pieces, 20 yellow white pieces, and 20 orange yellow pieces. So 20 plus 20 plus 20, that is equal to. So the answer choice for this question is B. Okay. So we just look at the solution here also. The number of small pieces with exactly two colors is equal to 20 plus 20 plus 20, that is equal to 60. How this 20 represents? This 20 represents, that is orange white. This 20 represents yellow white, and this 20 represents orange. Fine. So in total 20 plus 20 plus 20, that is equal to 60 such cubes we have here. And the answer for this question is. Now you can directly also write n minus 2 into 12, where n is the number of pieces at each of the dimension, along each of the dimension. And here n is equal to 7 we have. So 7 minus 2 into 12, that is equal to. Okay. So the answer choice is. Now move on to the next question. And the question is about here. How many of the smaller cubes have only white color on them? Only white color on them. Obviously, if I talk about only white color on them, it means there is only one painted face. Okay, and that must be lying at the faces only. So white color, only white means as per the white face. So just look at this. We have here 7 total pieces, and all the boundary based pieces are removed. So if all boundary based pieces are removed, then one layer is removed, remaining one from this upper, one from this lower. So remaining is 5 front and back 5. So 5 are 25 pieces are available with only one face painted. In other words, you can in other words you can also write it as total number of pieces at each of the faces is 49. Fine. Now total 4 edges, total 4 edges we have, and 4 fives are 20, and 4 vertices, that is 24. 49 minus 24 gives you 25. This is also one of the ways to get the value here as 25. I hope this is clear. These 4 vertices based are removed, 3 face painted, 2 face painted, 5 fours of 20 because of these 4 edges. So 20 plus 4, 24. 49 minus 24 will give you 25. Or this is the way, if boundary based pieces are removed, then the remaining pieces can have the shape. They all together can make the shape of cubes with 5 pieces on each of the edges. That is available for this. 5 into 5, that is equal to 25. I hope this is clear. So 25 in this white and 25 in this white. So 25 plus 25 in total, it is going to be how much? 50. So the answer choice for this question is 50. Now look at the solution here. We find the smaller pieces with only white color on them and are at the middle of the surfaces painted white, and it looks like that. That's what I had tried to explain here. So these boundary based pieces are removed. These boundary based pieces are removed because these are 2 or 3 face painted. Remaining are here 1 face painted. So this is representing as the required part of this one. Okay, so 5 pieces in this row, 5 in this row, 5 in this row, 5 in this row, 5 in this row. So in total we have 5 into 5, which is equal to 25 pieces, and at each of the faces. Since this is question about white, so at this white face, suppose if this is white face, then these pieces or these cubelets have only white color on them. Okay, and white, one of the face, and another face is also white. So 25 in each of those faces, 25 plus 25, that is equal to. I hope this is clear. So its answer is 50. Now we have got for white it is 50. Can I say because of its symmetricity, since orange are also of the same type? Okay, so 25 for orange also in this face, 25 in this face also. So can I say for orange also this is 25 plus 25, 50? And similarly For yellow also 25 plus 25, that is equal to 50. Okay. So can I say for each color phase, each color, only one color if I'm looking, that is whether only white color on them or only yellow color on them or only orange color on them. Each of these are how many pieces? 50 pieces. 50 plus 50. If there is a question of only one color, then that will include white, only orange, and only fine. So 50, 50, 50 for each of orange, white, and yellow. In this case, our answer is for white only, and that is choice D. Now, move on to the next question. Next question we have here. How many of the smaller cubes have exactly one color on them? That's what we have just discussed here. In the previous question, we had seen all the possibilities. So we already have seen that there are 25 this and 25 at this place. So for white, it was 50. Right? For orange also 25 this one, 25 this one, 25 plus 25. For yellow also 25, 25. So in total 50 plus 50 plus 50, that gives us 100. And its answer choice to be picked here as B. Just repeat here, the number of small pieces with exactly one color is 50 plus 50 plus 50. And you can say that 50 represents only white. This 50 represents only yellow. And this 50 represents only orange. Okay, I hope this is clear. So 50 plus 50 plus 50, we have total 150 cubelets. 150. Okay. So the answer choice is B. I hope this is clear. You can also apply that formula we have discussed in the previous set. N minus 2 whole square. Since n is 7, 7 minus 2 whole square. That is 5 whole square, 25. 25 into 6, that gives us 250. 150. Total number of faces we have 6. And at each of the faces n minus 2 square, 7 minus 2 whole square, that is 5 square, 25. Number of faces 6, 25 into 6 is equal to 100. Move on to the next question. So next question we have, how many of the smaller cubes have no color on them? So whether this whole cube, this bigger cube, is painted with only one color or three different colors or four different colors whole faces, it doesn't matter, it doesn't make any changes regarding the cubelets which are lying in the crux, which are lying inside this, because they are still unaffected with this painting process. Okay, so still the process means the status of those no color painted, no face painted pieces being the same. So whether it is orange, yellow or single color it is painted, the remaining the inside must be free from any color. Okay, so these all pieces inside will be zero face painted. And how many such are there? If you remove the layer, so one layer from each of the dimension, total 7 we have in each of the dimensions. So if one from each is removed, the 5 pieces will be looking, means 5 pieces will be available. And if you remove these all layers, okay, accordingly, it will look like this one. Okay, 5 piece here, 5 piece here, 5 piece here. Initially, it was 7, 7, 7. I hope this is clear. So total number of such pieces equal to 5 into 5 into 5, which is equal to 120. Now, so the answer choice for this question is C. So now look at the solution part. The number of small pieces with no color on them is n minus 2 whole cube. You can just go through that also as we have discussed in the previous, that is basic set. So if n is equal to 7, 7 minus 2 whole cube is represented as the total number of cubes with no color on them. I hope this is clear. And now 5 cube will give us 100. Answer choice to be given here is C. So I hope this is clear to all of you. This is, the concept is same. Whenever the question of this type comes, concept is always same. What type of concept? Three-phase painted pieces are lying at the vertices. Two-phase painted pieces are lying at the edges. One-phase painted pieces are lying at the faces. And no-phase painted pieces are lying at the crux. That is inside, completely inside cube. Okay, so this is the main concept. Okay, we already have seen in 28th question or in these questions the previous and minus 2 funda is applicable, but it is not the guaranteed for each and every such type of questions. So in those cases, the concept where two faces painted lying at the edges, one face is painted lying at the vertices, at the faces, three faces painted lying at the vertices. These concepts are very important when dealing with these type of questions. I hope this is clear. Now move on to the next question. Question number 29 to 36. Read this question very carefully. A pair of adjacent faces of a cube are painted orange. Second pair of adjacent faces are painted yellow, and the third pair of adjacent faces are painted white. This is different from the previous one. This is slightly more difficult than the. So if I try to make the cube, it will look like this. And in this case, we have here adjacent faces of orange, white, yellow. So I can assume adjacent this as orange, orange. Now this is white, white, not orange, orange. This is white, white. O for orange, this is orange, and this is also assumed to be orange. Now, yellow is also yellow faces are also adjacent to each other. So these are yellow faces and these are adjacent to each other. Now, in this case, if you look at this vertex, which is visible directly, how many how many faces are available? Three. So at each of the vertices, the pieces lying at each of the vertices will be here with three face painted. This is for sure. Okay. Now just cross check all the different colors are available or not. Now just look at this. White, white are adjacent. So this vertex won't have three different colors. Fine. It means if I am looking for any piece or any cubelites with three different colors, then obviously I have to avoid those edges which have two adjacent faces. So the vertices with those type of edges won't be considered. Avoid those. So I have here white, white. I have here orange, orange. So this is to be uh, avoided, and all the vertices relating to this edge will not be considered for three different. And now this edge is also orange, orange. So in that case, can I say this vertex is not to be considered, this vertex is not to be considered, and orange, orange, this vertex is not to be considered, this vertex is not to be considered. Now if I talk about yellow, yellow, so yellow, yellow is this one, because this yellow, this yellow, so yellow, yellow is this one. Now in this case, all the vertices on these edges won't be considered, right? So this vertex is not to be considered. This vertex is not. This vertex is not. This vertex is not. This vertex is not. And this vertex is not, because these vertices are related with the edges which have two adjacent faces, and there is no scope of all three colors being at those vertices. So out of total 8, these 6 vertices are removed. Now we are left with this vertex and this vertex. Now just cross check whether these two vertices have the three different colors or not. So this front is white, this is yellow, and this is orange. So can I say this vertex has all three colors on them? And this is to be considered. Similarly, just come to this. This is yellow, this is white, and this is here orange. So this is also here as the vertices with three different colors. Hope this is clear. So if I consider these vertices, Can I say the vertices are of this type? First, I can write all three different colorways. So now white, white, and orange. How many such vertices are here? Two vertices. And if I talk about white, yellow, how many? Only one, because there is only one is with white, and the vertices joining this are related to orange and yellow. So if I consider this is one vertex, we have white, yellow, and another vertex we have white, orange, another is white, yellow. So white, orange is also available, and one vertex. Similarly, come to that is this is with orange. Okay, so this vertex have two orange and one white. Okay, so two orange, one white. How many such pieces? Okay, one. Now come to this one. How many such vertices? One. If I talk about this, it's the second vertex, and that is this one. Orange, yellow. So orange, yellow is another one. Hope this is clear. So we have considered this is white is this orange is. Now come to yellow is. So yellow is this vertex and this vertex. This vertex has yellow, white. So yellow, white. And this lower vertex, lower face related vertex is having here yellow, orange. So yellow, orange. Total how many such pieces are here which are lying at the vertices but with only two colors? Or in other words, I can say the number of pieces the number of pieces with three painted faces but painted with exactly two colors. Why? Because these are related to the adjacent edges, means these are related to the edges with adjacent faces being same. So in this case, I can say these are three colored vertices and three colored pieces, and these are two painted face with two colors. Fine. So three painted faces with two colors on them. I hope this is clear. Similarly, if I talk about edges, there are how many such edges which have same color? So just look at this. White. This edge has white. So same color edges. Same color edges. One is white. Another is orange. Third one is yellow. Right? These are same colored edges. Okay. And the pieces which are lying at the edges are painted with two colors, but they have painted with two colors, means painted with two faces. I can say these are the pieces with two painted faces, but with only one color. Okay. Now, out of those 12, remaining edges have two different colors on the two painted faces. So these are the conclusions, these are the observations we have made. Now move on to the question part, and we will deal with question by question. Fine. So this is the cube, it looks like, and I can explain by it also, but we already have discussed. Now move on to the question part. Now that cubelet, that whole cube could be looking like this one. Fine. This now with 7 pieces at each of the edges. Okay, fine. Now question number 29. How many of the smaller cubes have all the three colors on them? We just have seen that all these three colors, all these three colored vertices are how many? Only two. Only two vertices are there which are having all these three colors, and number of such pieces is equal to only two. So the total number of pieces with three different colors on them is I hope this is clear. So the color combination of the 8 cornered pieces is as follows. That is white, yellow, white, orange. That's what I have just discussed here in the previous slide. That is 2 pieces, white, white, orange, 1 piece. And just ignore this one because this is repeated here. Now come to next one. White, white, yellow is 1. Fine. Then yellow, yellow, orange is 1. Yellow, yellow, white is 1. Orange, orange, yellow is 1. Okay, and orange orange white is also 1. So we already have seen in the previous discussion that these are the things, and we have found these at the vertices of the edges with same color. Okay, so in these ways these are very important edges. Okay, white white, orange orange, and one behind this one, that is. Okay. So the answer for this question is only 2 pieces have all 3 colors on them. Move on to the next question. Answer choice is D for this one. Next question. Question number 30. So question number 30. How many of the smaller cubes have only orange and white on them? So only orange and white on them. So we already have seen that out of those 12 edges, 3 edges are with 3 edges are with same colors. So out of those 12, 12 minus 3, that is equal to, there are 9 such there are 9 such edges. Okay. Now because of symmetricity, I can say 9 by 3 there are 3 such edges which are with orange and white. This is the way we can directly get the number of edges. Now, if you have any doubt, you can just go for the counting also. Only orange and white. Orange and white. So this is orange and white. One is. This is orange, orange. Okay, this is not to be considered. Now this is orange, white. Fine. So this is orange, white. This is orange, white, and this is. So total how many edges are here? 3 such edges. And at each of the edges we have we have 5, 7 minus 2, 5 pieces. So now the number of pieces with 2 painted faces, and that is with only orange and white, which is equal to 3 into 5, that is 15 such pieces. But wait, is this the answer for this question? Just wait, just look into the language. How many of the smaller cubes have only orange and white on them? Is it written that these these pieces are with only 2 painted faces? No, written. It means it can also consider, okay, those pieces with all faces painted with orange and white can also be considered. If it is possible, then it will be considered. Fine. So the meaning of the thing I have explained is, I have just said is that in this case it is not necessary to have only 2 painted faces. There is a possibility of 3 painted faces with orange and white only on them. That is also to be considered. Fine. So this represent orange white with 2 painted faces. Now if I talk about with 3 painted faces, so with 3 painted faces that must contain only orange and white. So orange and white, only orange and white, this vertex. Fine. So this vertex or WWO and this vertex OOW. So these are coming in that category. So WWO, one vertex, and OOW is another vertex which have 3 painted faces but only orange and white. One this, one this. Total, this as well as this is to be considered. This is 2 painted faces space, this is 3 painted. Any doubt? So 15 plus 2, this 15 plus these two is equal to 70. So how many of the smaller cubes have only orange and white on them? That is, two painted faces base is 15 and three painted faces base is 2, to 15 plus 2, that is equal to. Now look at the solution. I repeat here with the solution. Number of orange white edges is 3. I hope this is clear. Now total number of vertices with orange and white only is 1. Total number of, that is, two side white and one side orange. Similarly, two side orange, one side white is also a possibility. That is also. So number of pieces at each of the edges is 7 minus 2, that is 5. So total number of pieces along the edges, such edges is, that is, two painted faces with orange and white is 5 into 3 is equal to 50. Now those 1 are also to be added, and that 15 plus 1 plus 1, that is giving us 70. So the answer choice for this question is A. I hope this is clear. Now move on to the next question. Question number 31. 31 we have, how many of the smaller cubes have exactly two colors on them? And we have just discussed that in the previous question that included with exactly two colors along with three colors. But in this question I have to consider only exactly two colors on them. How many of the smaller cubes have exactly two colors on them? Now, exactly two colors. In the previous question we had about orange and white, and we had seen orange and white color based. How many pieces were there? 70. So exactly two colors. This is not about only two painted faces. It can consider with three painted faces also. But colors, number of different colors would be two only. Okay. So as we had seen, orange and white, we had how much? 70. Similarly, can I say orange and yellow will also have 70? And yellow and white will also have. Fine. Why? Because again this question is not about counting those pieces with exactly two painted faces. This is to be counted for those pieces with two colors, exactly two colors, but not exactly two painted faces only. So it can be exactly two colors with three painted faces. Fine. So one of the ways is to go for exact calculation of orange white. We already have done in the previous question. Orange, yellow, and then yellow, white, 17, 17, 17. That gives us 51 as the. Fine. Another way of doing the question is, first calculate total number of such pieces with exactly two painted faces. So exactly two painted faces if I am talking about, these are lying at the edges. How many edges are with exactly two colors? There are 12 minus 3, 9. There are 9 such edges with exactly two colors. So in that case I can say 9 into 5 at each of the edges. There are 45 pieces with exactly two painted faces and with exactly 2 colors. 45. Now in the first question of this set we had seen out of those 8 vertices only 2 had 3 different colors on them and remaining 6 had exactly 2 colors on them, and those 2 colors based pieces will also be coming in this category, and 45 plus 6 gives us. That is another way of getting the answer for this. Now I repeat here, I go with the solution. So the number of small pieces with only white and orange color on them we already have seen in the previous question, that was 70. In the similar way, can I say the number of small pieces with only white and yellow is here 70. I hope this is clear. And similarly, only white and orange is also having 17. So 17 plus 17 plus 17, that is equal to, the answer choice for this question is. I hope this is clear. So you can also write n minus 2 into 12 and plus 6. Okay. In that case, it would give you, that is 51. Now come to the next question. Question number 32. How many of the smaller cubes have exactly two painted surfaces in two different colors. How many of the smaller cubes have exactly two painted surfaces in two different colors? Now it has categorically mentioned that, it has clearly mentioned that exactly two painted surfaces. And while doing the counting in the previous question, I have just calculated this here separately. That is exactly uh, two painted faces with two colors and exactly three painted faces with two colors I had discussed, and that was calculated as 9 into 5 plus 6 we had calculated. This 9 into 5, 45 pieces are coming in this category. That is exactly two painted surfaces in two different colors. Now, I just want to go into a detail of this one. How? Just find out how many edges are here with two different colors. We have one of the wedges, total 12 edges we have, and out of those 12, 3 are with same colors, white, white, orange, orange, and yellow, yellow just behind. So can I say 12 minus 3? There are total 9 edges with with two different colors. Okay, and those 9 multiplied by 5 is giving us total 45 such. Or you can do the counting here. So ignore this is, ignore this is, and ignore this is. Each of the remaining edges will have definitely two different colors. Okay, see this is here. This is not to be considered. This is not to be considered, and this is not. It has white, orange. It has white, orange. It has yellow, orange. This has yellow, white. Okay, this has yellow, white, and this has here orange, white. And if you go for this behind this one, that is yellow, white, that is orange, white. So yes, whatever the things we have discussed, those are total 9. 9 into 5 is coming out to be 45. I hope this is clear. Now look at the solution. Yellow, white, there are 3 edges. Orange, white, there are 3 edges. Orange, yellow, there are 3 edges. Yellow, white, if I am talking about yellow, white, okay. Or if I am talking about orange, white, yes. Orange, white, one such is. Orange, white, another such is. Okay. And orange, white, this is third. Total how many orange, white edges we have? 3. And 3 edges for orange, white. Similarly for yellow, white. Similarly for orange, white, orange, yellow. These are 3 edges. And at each of the edges, there are 5 such pieces. 15, 15, 15. That is coming out to be 45 such pieces. I hope this is clear. So the answer choice is B. Now, move on to the next question. Question number 33. How many of the smaller cubes have exactly one color on them? So exactly one color on them, where can it lie? So it is not clearly mentioned that only one face. It is simply mentioned that only one color on them. Okay. It means only one color with two painted faces, only one color with three painted faces if possible can be considered. Okay. So I can write here it as only one color. Okay. So only one color with one face painted, only one color with two face painted. Three face painted is not the possibility. So we have to consider all this. So now, if I look at this here, total number of faces is how much? 6 faces. And at each of the faces, we have how many pieces? Out of those 7, the pieces at the boundary are removed. So remaining here is 5, here it is 5. 5 into 5 is giving us 25 at each of the faces. Okay. So total number of pieces with only one painted face is equal to 25 into number of faces 6, 25 into 6, that is equal to 1. So one face Means only one color with only one face painted. That is equal to 25 into 6. That is equal to how much? 1. But since this question is not categorically mentioned that uh, only one face painted, that's why we can go with the pieces with only one color but with two painted faces can also be considered. And these are lying at the edges. So white edges is one. There are three edges with there are three edges which are with only one color. One is white, another is yellow, and third one is orange. I hope this is clear. And at each of the edges, number of pieces we have as 5. So 5 plus 5 plus 5, there are 15 more pieces to be included in this. 150 plus 15 is coming out to be 1. So the answer choice for this question is fine. I hope this is clear. I'm just going to repeat with the solution here. So white is how many? 1. That's what I have just made. Similarly, yellow is how much? 1 is, and orange is also. At each of these edges, there are 5 pieces. Number of such pieces is equal to 5 into 3 or 5 plus 5. That is equal to. Okay, fine. I hope this is clear. So this part gives us 50. Now come to those pieces which are lying at the faces and which have exactly one painted face with only one color. So white face, how many such faces are here? 2 faces. This one. Similarly, yellow, 2 faces. Orange, 2 faces. And at each of the faces, there are 25 such pieces available. So 25 into 2, 50. 50 plus 50 plus 50, can I say there are 150 such pieces? Okay. Or 5 into 5, 25. 25 into 2 plus 2 plus 2, 6, 150. These two faces, these two faces. Now these 3 edges are here. Okay. So in this way, we can do this calculation together here. 25 into 6 plus 5 into 3, and that gives us 165. So the answer choice for this question is C. I hope this is clear. Now, come to the question number 34. So, question number 34, how many of the smaller cubes have exactly one painted surface in exactly one color? So, these are obviously lying on the faces. This is the part of just previously discussed question. And that is lying on the faces. We already have seen 2 plus 2 plus 2, there are 6 faces. 25 into 6, which is equal to 150. So 150 are pieces, and the answer choice to be picked as. I hope this is clear. Now, come to the next question. How many of the smaller cubes do not have white color on them? So do not have white color on them. Okay. So suppose I have this piece, this cubelet. Okay. So if I have this cubelet, what we had discussed till now, white here, I can remove this layer. Do not have white. So this white layer is to be removed. Right? So if I remove this layer, okay, can I say remaining are with no white? Remaining with no white. Right? So if I remove this layer, this will have only 6 in this dimension, and this will have only 6 in this dimension. So after this removal of this layer, it will look like this. Right? So this is removed from this, and this is remaining here. So we have here 6, but in this layer, in this dimension, there are 7 pieces. So can I say the total number of pieces we can have here as 7 into 7 into 6, and that is not 7 into 7, that is 7 into 6 into 6. 6 into 6, 36. 36 into 7, that gives us 252 such pieces. See, I hope this is clear. I'm just going to explain with this also. So I have just done the same thing. One layer, if layer of white color is removed, then this remaining part, okay, the remaining part will be looking like, because this layer is removed and now remaining part is looking like this one. 6 is remaining, 6 here and 6 here, and this will still have 7. So this is still having 7. Okay. Total number of such pieces remaining here is 6 into 6 into 7. That is equal to 252 such pieces. Answer choice to be. I hope this is clear. Now move on to the next question. Question number 36. How many of the smaller cubes have yellow or orange but no white color on them? Now, no white color on them, we just have discussed in the previous question. So we have seen here 252. And it says that only yellow or orange. Okay, no white. White is already removed. Only yellow or orange. Okay. So out of these pieces remaining, this inside, these pieces in the crux are the pieces with no color. Fine. Pieces with no color on them. If I remove from this list, can I say these remaining pieces available will be either yellow or orange color? Yes. So 252 minus no color, that is 125 if removed, the remaining are 127. So our answer choice for this question is going to be 120. Okay. So the difference between this question and the previous question is that here the pieces without any color should be subtracted. What I have just said here. And 252 minus 125, that gives us here 120. Okay. So the answer choice for this question is here 127, and that is A answer choice. Okay, fine. The last question I am going to discuss here is a dice is thrown 3 times. This is slightly different from the previous question I have discussed here. A dice is thrown 3 times and its 3 positions are given. Select the alternative which provides correct answer to the questions asked. Which symbol is opposite? Is exclamation mark. Just look at this here. If I rotate this one, so in this case I have hash sign here, but this is not to be matching with this. Now look at this. At the rate goes upside and dollar is in the left side. So I can relate these first and third figure. Right? So if this at the rate, okay, moves up, then hash sign goes to this one. So can I say hash sign is here? Okay, and in this case phi is here. So can I say phi and hash are opposite each other? So phi and hash are opposite. Right? So in this case we have phi here. Now once we have got this hash here, now in this case if you compare this one, I can, if rotate this by this anti-clockwise direction, if this is done, then hash comes here, this is okay, but theta cannot be at the top and exclamation mark cannot be here. Okay, so we can just see here in different perspective. Okay, just I can say that if hash comes here, fine. So if hash comes, then it will look like this one. At the rate hash dollar and phi sign here. So this is not matching with this one. If I take the opposite of this one, okay, इसे अगर मैं पलट दूं, then if I see from this, if I see from this side, I'll have here theta just opposite, theta just opposite which one? And that will be here as theta will be just opposite at the rate. We have hash opposite uh, phi. Theta will be just opposite at the rate. And exclamation sign will be just opposite dollar. Right? So this is to be seen from the different. If I completely rotate this in this way, I'll get this as phi opposite hash, theta opposite, and this is opposite dollar, theta opposite, which one? At the rate, and exclamation sign is opposite dollar. Hope this is clear. So in these ways, by doing this rotation or seeing from the different angle, just opposite angle, if I see here this one, I'll get this kind of thing, and this is possible if theta is here. See, this is at the top. It is not possible to replace this by this. So if I see uh, in the opposite angle here, so hash is here, then if at the rate is not possible, then obviously this theta is possible. So if theta comes in the top, then it will look like this. And similarly, opposite to dollar, it will be exclamation mark. The answer for this question is here, dollar. I hope this is clear. So now we have discussed a lot of questions with higher difficulty level. I hope this was very good for you and you understood this whole. Fine. Thank you.